Hello, this is the second video of the Linear Programming 2 series on the simplex method and integer programming for OCR Discrete Further Mathematics, and introduces the idea of slack variables used in the simplex method. The standard form for a linear programming problem is shown below, with the objective function as being maximize 5x plus 3y minus 8z, and the constraints, which are inequalities and noting the non-negativity. However, you may remember that when we graph those constraints, we draw equations of lines in 2 dimensions. And the algebraic solution method, or simplex method, also needs equalities or equations rather than inequalities. Let's have a look at this example to introduce slack variables. Given a 12-metre roll of cloth to be used to make some dresses and some skirts, we note that a dress needs 3 metres of cloth and a skirt needs 2 metres. The decision variables are: let x be the number of dresses and y the number of skirts. The constraints will be related to this information here, and therefore 3x plus 2y less than or equal to 12. We also need to note that x and y are non-negative. So if we look at the 12-metre roll stretched out for 2 dresses and 1 skirt, or for 2 dresses and 2 skirts, we can see that the amount of leftover or slack cloth varies, but it must always be greater than or equal to 0. In other words, we can only use up to the limit of the total resource given in the question. So if we introduce a new variable or slack variable s, then we can write that 3x plus 2y plus s equals 12. We still have a non-negativity, but we also note that x, y and s must all be greater than or equal to 0. Going back to our original linear programming problem, we will need 3 slack variables. Now, we can call these s, t or u, or we can call them s1, s2, s3. It doesn't really matter. So we had our objective function to maximize 5x plus 3y minus 8z, and then we had the constraints including the non-negativity. Introducing 3 new slack variables means that we could write these as x minus z plus s1 equal to 1, x plus y plus s2 equal to 2, and 3x plus 2y minus 4z plus s3 equal to 6. We would also have x, y, z, s1, s2, s3 all greater than equal to 0 as the non-negativity. This is sometimes called the augmented form, and is a necessary step before we set up the simplex tableau. The slack variables s1, s2, s3 give the method a variable on which to place a value, which must be greater than or equal to 0, and may well be 0 by the end of the method, but also just indicates how much slack there is in the system, because not all the constraints will necessarily be at full capacity. In the next video, we will see how to set up a simplex tableau based on this augmented form of a linear programming problem.